In the second method, we're going to start expressing secant x as 1 over cosine x using inverse trigonometric identities. So we know that secant x is equal to 1 over cosine x, so we can express this integral as 1 over cosine x dx. Now we can express 1 over cosine x as cosine x over cosine squared of x, because cosine x divided by cosine squared of x is equal to 1 over cosine x. So our purpose is to use cosine squared of x from Pythagorean identities. We know that sine squared of x plus cosine squared of x is equal to 1. If you pull cosine squared of x in this equation, you obtain 1 minus sine squared of x. So we can express cosine squared of x as 1 minus sine squared of x. Now we're going to make substitution. Let y be equal to sine x, then dy will be the derivative of sine x, which is cosine x dx. And if you solve for dx here, you get 1 over cosine x times dy. Now let's write everything in terms of y. So our integral turns into cosine x over 1 minus y squared times, instead of dx, we have 1 over cosine x dy. Cosine x's cancel out, so we have integral of 1 over 1 minus y squared dy. Here we're going to apply partial fraction decomposition. For this, we need to disintegrate this into the factors. So our denominator will be 1 minus y times 1 plus y using the difference of two squares. If we have a squared minus b squared kind term, then that is equal to a minus b times a plus b. In our case, we have 1 squared minus y squared is equal to 1 minus y times 1 plus y. Now we have the factors, so we can apply partial fraction decomposition. So we know that this fraction is equal to a over one of the factors plus b over the other factor. Because we have linear factor here, then we use constant. If we have quadratic factor here, then we apply linear numerator. If we have cubic factor here, then we apply quadratic numerator. You can check partial fraction decomposition videos I have and understand this part better. So here our purpose is to solve for a and b. So for this, we multiply the whole equation by the common denominator, which is 1 minus y times 1 plus y. So this whole expression, 1 minus y times 1 plus y, multiplied by the first fraction, gives us just 1. And the same expression multiplied by the second fraction gives us just 1 plus y times a, because 1 minus y cancels. And this whole expression multiplied by the third fraction gives us 1 minus y times b, because 1 plus y and 1 plus y cancels. 1 minus y times b stays. Here we are going to solve for a and b. Let's apply giving value method. Let y be equal to -1, so 1 minus 1 is 0, 0 times a is 0, so 1 is equal to 1 minus minus 1 is 1 plus 1, which is to b. Then from here b is equal to 1/2. And let's give another value for y. Let's give value of +1 this time. So it's gonna be 1 is equal to 2a. This is gonna be 0 because 1 minus 1 is 0. From here a is equal to 1/2. Now we know our a and b, so we can rewrite our integral using partial fraction decomposition. Instead of a, we have 1/2 1 minus y, plus instead of b, we have 1/2 1 plus y. Now we can pull 1/2 in front of the integral sign. So we have 1 over 1 minus y plus 1 over 1 plus y dy. And if we negate both fractions, we obtain 1 over y plus 1 minus 1 over y minus 1. So all we did was to negate these all fractions. Now we know how to integrate this. This is the integral of ln. So we have 1/2 times ln of y plus 1 minus ln of y minus 1 plus c. Now, using the logarithmic rules, we can condense these two ln's. If we have subtraction, we can condense it using division. So ln of y plus 1 over y minus 1 plus c, and we have 1/2 here. Now we're going to bring y back. We said that y is sine of x. So what we have is 1/2 ln of sine x plus 1 over sine x minus 1. So this answer is nothing but the same answer as the method 1. Sine x plus 1 over sine x minus 1 is secant x tangent x. Let's show how it is. If you square the numerator and the denominator, you obtain sine x plus 1, the quantity squared, over sine x minus 1, the quantity squared. So this is from the Pythagorean identity. We know that this is going to be negative cosine squared of x. And if we rewrite everything, we have 1/2 ln of sine x plus 1, the quantity squared, over negative cosine squared is positive cosine squared, because any negative value squared will be positive. So we can express it as cosine squared of x. Now we have both squares on numerator and the denominator, so we can wrap it in the same parenthesis. And using the logarithmic rules, we can pull it in front of the ln. So 2 times 1/2 is just 1, so we obtain ln of sine x plus 1 over cosine x. Now we have common denominator cosine x that we can separate this fraction. So sine x over cosine x plus 1 over cosine x. We know that sine over cosine is tangent, and 1 over cosine x is the secant x. So this is the same answer as we obtained on method 1. So integral of secant x dx is ln of tangent x plus secant x. In the method 1, you need to remember to multiply which expression to multiply and divide. In the second method, you need to go through thoroughly all rules, and you need to know partial fraction decomposition.